Hello, in this video I'm going to demonstrate the use of while loop in Java by creating a project first. Let's say using while loop. We'll add a class to write our code and I'll call it as program01 part of package code.vinod. Add a main and let's check it out. A while loop is very similar to the if statement in terms of syntax, but in behavior it's totally different. So imagine I have a num which is some number 29 and then I want to print a multiplication table of the same. So and imagine I want to print from 29 times 1 through 29 times 10. So I need a loop variable, so I'll declare int I equals to 1. I can check while I less than or equals to 10, and then I can use a statement like I++ to ensure that the variable I changes its value. So somewhere down the line I will be I less than or equals to 10 fails and the loop is terminated. Now otherwise, as long as this condition is true, this block will be executed continuously. So let's go and print it out, and to print I'll use printf. Printf can be used with %d, %d and another %d. Ensure that you use a new line, otherwise automatic new line will not come. So I'll use here num I and num times I. So now that it is finished, let's just go and execute this. We'll also print here end of demo as a statement, save it and execute this code to see if the results are going to be as expected, and as you can see the results have come correctly. Had I not given this, then you will see that it's never going to stop and it's going to be considered as an endless loop because the value of I is always less than or equals to 10 because its value remains 1 itself. So this is an endless loop. So ensure that the loop is terminated by altering the value of your loop statement. So I'll say I++. Now let us also have a look into an endless loop, how I can use that and come out of that too. So let's right click, new class, program02, and then I'll create a main function. I'll use a similar variable int num equals to some number, and then I'll say int I equals to 1. The endless loop intentionally can be given as while true because all this while loop expects is a true or false. Of course, if it is false, it will never execute this. Now, instead of controlling that with an expression or a variable, I'm giving a hard-coded value true. So which means we are telling the compiler that, hey, it is true. So if you give here a sysout and say end of demo, you can see that compilers are identifying that this is a unreachable code. If you move the mouse on this error, it says unreachable code. So because of the hard-coded value, compiler is able to figure out that. Now, however, I can change the course of that by using a print statement first. So I can borrow the print statement from the previous code. And of course, I can also say I++, and then I can check if I happens to be greater than 10, then I can say break. Now note that now compilers are able to figure out that inside the while loop somewhere you have used a break. Now what if I have not given this? Now if you are not given this, compiler is not going to check. It says that there was a break found and this might be possibly reachable code. So anyway, in this particular case, it is reachable. We'll execute and see how this works. So you can see that we're able to get a similar output as in the previous case. So when do you use this while loop? Now a while loop is preferred generally when you don't know how many times the loop will go for. Okay, so if you know how many times the loop goes, then this is not a right loop. For example, let's say we want to find out the Fibonacci element less than probably a number. So in such case, I can use a while loop. Let's go and create that. We say program 03. We'll add a main. And we want to find out the Fibonacci element. So let's use this logic. I'll take this A, B, and C. Now in Fibonacci, you will always start with a 0, then 1. Then the third number or the next number is a sum of previous two numbers, which is 0 and 1, that is 1. So the next number is a sum of the previous two numbers, which is 2. and then 3, 5, 8, 13, 21, 34, etc. 55, etc. So imagine I want to now I want to specify a limit and say, hey, print all the Fibonacci elements until 100. So I don't know how many times that I have to go for. So while loop would be a good candidate here. So I'm going to go assign a equals to -1, b equals to 1. Now I'm applying this logic because -1 plus 1 will be the first value of your Fibonacci element, and then I can swap the numbers and then continue the same thing. So let's go ahead and do this. So I'll say here int limit equals to 100. Let's assume that I want all the Fibonacci numbers that are less than 100. So we can check here by using while probably. Now C, which is the Fibonacci number at any given point in time, right now C is not being initialized. So I'll go with a true, which is an endless loop, and then check here C equals to A plus B, and then we'll print that. We'll say here, hey, this is the first Fibonacci element, and then we need to swap. We'll say A equals to B and B equals to C, and that swapping will ensure that we are picking the next two elements and summing it up. But when are we going to break this? We're going to break this if C after calculation has been more than 100. So we'll say that if C is less than 100, you do this, but if it's greater than 100, then that's we have crossed the limit, we'll say break. And note that as soon as it is more than 100, it's not even going to print, it just breaks the loop. Now this would be a good candidate for a while loop. Of course, we could still prefer a different loop for this because we don't know when this condition is supposed to be broken. So we execute this. Of course, we should check here limit instead of 100 so that we can make use of this variable and change its value to something else. So let's go and execute this and see if the result is as expected. And you can see that we get 0, 1, 1, 2 up to 89 because the next number would be more than 130, I guess 144. So if I give here 150, another additional number would be displayed. So 144. So if I make it as around 1000, and I should get some more numbers as part of our Fibonacci series. So this is exactly how you use a while loop.